Let's now take a look at the DBT viewpoint, which, as we mentioned, is really a philosophy for how modern analytics teams should function. And before we can even get into that, we need to take a minute to understand how we even got here. So let's take a brief history of data engineering. If we go to the early 2000s, you'd mostly see traditionally on-premise databases, row-based, managed almost exclusively by database administrators. Maybe they're small teams, but mostly DBAs. Next, if we go to the mid to late 2000s, you start to see data warehouses becoming pretty much universally seen anywhere. You have ETL pipelines, so extract, transform, load. And I'll point out that a lot of times these ETL tools are one size fits all for the whole pipeline. Now, by the early to mid 2010s, this is where cloud computing starts to take off. So we move from the traditional row-based on-premise to cloud computing. You start to see siloed data teams. So you start to get away from having maybe a single unit that's representing everything, and it kind of becomes more of an issue. And there's more of a transition to ELT pipelines, and you start to see kind of one-off tools as opposed to one cohesive tool doing an entire pipeline. And that's kind of where DBT starts to fit in. Now, the early 2020s and beyond, this again is DBT is really leading the forefront of this next era, which is introducing more software engineering into the analytics workflow. And lastly, specialized tools. It builds on that ELT pipeline concept where it's not one cohesive product. We have a bunch of different tools interacting with cloud databases and cloud products to put it all together. And here are a few of the tools and a couple of examples. And you can kind of see the progression of when these innovations start to happen, which leads us to today. With all of that in mind, you could summarize the viewpoint into three main concepts. It's one, analytics is collaborative. Two, analytics code is an asset. And three, analytics requires automated tools. We got to 2020 and beyond, and we're saying these are the things that are important for modern analytics teams. So let's look at these one at a time. First, analytics is collaborative. What does that mean? Well, there's four really main subpoints here. First is version control. Code evolves, and you should always know what changed and when. And a great tool for version control is GitHub. Quality assurance. Any code that generates code for analysis should be reviewed and tested, just like software engineering. If you're going to make a product, you need to test it. And traditionally, that really wasn't an expectation for data. So that's why it's really important here. Third is documentation. Package your code with descriptions for how it should be interpreted. Fourth, modularity. Create data sets that are consistent and can be easily updated as logic changes. So all of this stuff is saying we're working together. There's a lot of people with eyes on it. We need to be smarter about how we build an analytics tool or an analytics product. Second is analytics code is an asset. So number one, analytics requires multiple environments. You really shouldn't be going straight to production. Service level guarantees, errors should be treated with the same urgency as bugs in production software. You're probably starting to see a theme now here. We're kind of bringing analytics into the software engineering world and implementing those concepts. And design for maintainability, most of the cost in development is in the maintenance phase. And if you've been a data engineer in any capacity for a while, you know this is true. People come in and build things just to get through a particular project, and you don't think about the long-term maintenance, but that is where the cost and the time is spent. So design it with that in mind. Lastly, analytics requires automated tools. Reduce manual workflow steps so you can reallocate your time to more value-added engineering tasks, things that you can bring to the table. Anything you can automate, you should automate. And run with a single command. All steps should be wrapped together and easily executed in order. It just makes it easier. So bringing it all home here, the viewpoint combined with an actual product that can help you build in this way and design all this stuff, all of that together is DBT. That's why I always say you can't just learn how to use DBT without understanding the viewpoint and why it's so important. It's kind of bringing all those concepts together. All right, so that does it for this lesson. Take a minute to reflect on kind of what we just covered and why this is so important and how we got here. And in the next lesson, we're going to now get our hands dirty and start to set up our own local environment so that we can use the DBT command line tool and start to build our own project.